This video will cover Year 10 quadratics graphing. For anyone following along with the test preview, I'll put time tags down below with question numbers so you can just skip to the question you need help with. Otherwise, I've tried to put some tags in for anyone else and a description of what those questions are about if you're looking for help with a particular sort of question in this topic. Question 1 wants us to find out x-intercepts, y-intercept and turning point of the three following functions. So what we'll do is have a look at the format that it's written in. The first question is in expanded form, which is great. Straight away we know what our y-intercept is. So we've got our y-intercept happening here when x is 0, y is 12. You can substitute it in if you like, but you can also just identify it by having a look at the constant on the end. If we're ready to find out x-intercepts, best way to do this is to use null factor if you possibly can. So we're going to take the equation, we're going to make y equals 0, and I'm going to factorise it. So I'll take 3 outside of x squared minus 4, and then I'm going to continue to factorise. 3 can stay out the front and I'll ignore that. This will become 3 plus 2 multiplied by 3 x minus 2. And so we've got x values of plus or minus 2. That means that our x-intercepts happen when x is minus 2, y is 0. And they also happen when x is 2, y is 0. Now all I need is my turning point. One of the ways to find out the turning point is to find halfway between the two x-intercepts, and that will give me the x value of the turning point, so I'll do it that way. So I say 2 plus 2, minus 2 plus 2 divided by 2 will give me 0. And so if I then substitute that into the original equation, y will be 3 times nothing squared minus 12, which of course will give me the answer minus 12. So I have a turning point where x is 0, y is minus 12. Just so happens that that's also my y-intercept. I've named it up for my marker. In the second one, the equation looks slightly different. You can see that it's missing its constant on the end, which means that straight away I know that the constant is 0. So my y-intercept happens when x is 0, y is also 0. I'm going to have some x-intercepts for this one as well. And also I'm going to need to find my turning point. We'll do it in the same way. So the first thing I'm going to do is I'm going to use null factor. So I'm going to make y equals 0, and I'll factorise that equation so that I've got x outside of x plus 4. That gives me x values of 0 and minus 4. So my x-intercept happens when x is 0, y is 0, and when x is minus 4, y is 0. Now I just need a turning point. What I'm going to do is the same thing, find halfway between my x-intercepts. So I say is my turning point. I'm looking for 0 plus 4 divided by 2, halfway in between them. 0 plus negative 4. And so that will give me an x value of minus 2, which I'm then going to sub back into the original equation. So y, or the y value of my turning point, will be when I've got minus 2 squared plus 4 times minus 2, which gives me the answer minus 4. So my turning point is when x is minus 2, y is minus 4. My 3 answers for my marker up here. I'm going to move on to the last one. The last one is in turning point form. So again, we are still finding our y-intercept. We're trying to find our x-intercepts. And I want my turning point. But I'm going to change the order that I do things this time. When it's in turning point form, it's a fantastic way of seeing the turning points straight away. I'll just use this value here and this value here. We call them the h and k value. Don't forget that when you put in your x value, it's reversed. So it's positive 1 up there, it becomes negative 1 at the bottom, and the negative 7 stays the same. So I've got my turning point. Now what I need to do is I need to find my x and y intercepts. There's a couple of ways of doing this. One way that I think is probably simple to watch and understand is that if I take my original equation here and I expand it, so I'm moving it into expanded form here. So y equals x squared plus x plus x plus 1 minus 7. Okay, so I've just expanded this out. Now I'm going to collect my like terms. Whoops. I've got y equals x squared plus 2x minus 6. And now I want to factorize this. Now, it would be great if I could use the null factor method here, but that's not going to work. So another way that I could do this is I could use the quadratic formula. So I might do that. Remember, our quadratic formula is x equals minus b plus or minus the square root b squared minus 4ac all over 2a. And so if I substitute in my values, then and remember that if I just cheekily write it in here, this is going to be your a value, this is going to be your b value, and this is going to be your c value. Okay, so there's a 1 here. So if we substitute those in, what we'll end up with is x equals minus 2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1. And then you need to put that into your calculator. You'll find that x is negative 3.65 or positive 1.65. And so now we go back up for our x-intercepts and we say, rightio, when x is negative 3.65, y is 0, and when x is 1.65, y is 0. And we can also get our y-intercept because we've got a constant after we expanded it. So that means that up here, when x is 0, y is minus 6. And I've got my 3 answers for my marker. In question 2, we're being asked to find an equation. We've been given 2 points. One of them is a random point, that's this one here, and one of them is a turning point. So at this stage, the best thing to do would be to use the turning point form. And the turning point form is when y equals ax minus h squared plus k. Now this turning point form that I've just written here changes from formula sheet to formula sheet. We use h and k here. Sometimes it's b and c. Using h and k just so we don't get confused. So remember that this will be our h value, this will be our k value, and ultimately these can become our x, y coordinates. Okay, so we'll use them as we solve the equation. So let's start with subbing in our h and k values. We've got 3 as our h, so it will go in as a minus 3. We've got minus 5 as a k value, so it will go in as minus 5. We only switch the symbol on the one going into the brackets. Now we don't know what our a's are or our x's or y's, so what we'll do is we'll substitute in our x, y coordinates to solve for a. So y will become 11, still don't know a, x will become -1. Now we're just solving. I've got 11 on this side, and on this side I've got -1 minus 3 makes -4, -4 squared is 16, 16 minus 5 is 11, oops sorry, 16, so we've got 16a, and still a -5 here, pardon me. Balance method, add 5 to both sides. All I have left over here is 16, and on this side I've got 16a, divide by 16, both sides, all I've got left is 1, all I've got left is a. So I know that a is 1 now, so now all I need to do is just write out the equation. So I go back to this step here and pick this up and replace the a with a 1. So I end up with y equals 1 times x minus 3 squared minus 5. Remember, technically there's a 1 sitting here, but we don't need to write it in. So our final answer is this equation. Question 3 is very similar to question 2. We're given a random point on the parabola, and we're also given a turning point. So we're going to use the turning point form again. So we'll begin with y equals a outside of x minus h squared plus k. If you've just joined in at this point, remember we use h and k in our formula, but it's often different letters. Often it's b and c. We use this so it's not confusing with the expanded form. And what we're going to do is we're going to identify that the turning point has a value of h and k. So that's what will be subbed in as h and k, and we'll use this as our random x, y coordinate so that we can solve for a. So we'll start by subbing in our h and k values. Now h is a -1, so it will go in as a +1 into the brackets. K is a +2, so it will remain a +2 outside of the brackets. Now we don't know what x, y, or a is, so we will take our random point, 3 minus 30 on the line, and we'll substitute in to solve for a. So y will become -30, a is unknown, x becomes 3, and now we'll solve. I'm left with -30, 3 plus 1 is 4, 4 squared is 16, so I've got 16, it's supposed to be 6, 16 groups of a and 2. Balance method, I'll subtract 2 from both sides. On this side I'm left with -32, and on this side I'm left with 16 groups of a. Now I'm going to divide both sides by 16 to get a by itself, and a will be -2. Now all I need to do is pick my equation up here that I started to form and substitute in a for the answer. So my answer will be y equals -2 x plus 1 squared plus 2. No need for me to move this into an expanded form. The question doesn't ask for it, so this one's been answered. Question 4 is asking us to give an equation for a quadratic that has been reflected and then it's been translated. So if we don't have to draw it in the question, but so that we are all on the same page, the original equation, this one here, would have looked something like this. And then once it was reflected, it would have looked like this. And then it was translated, which means that the turning point was moved from 0, 0 here to -7, 4. So ultimately, the equation ends up looking like this. So if we do this simply, and then we go through how to describe this if you are asked how to do that as an extension. So first of all, if you start with the equation y equals 5 x squared and you reflect it, it simply becomes negative. It goes from being a happy face to a sad face, if you like. The red lines on the graph. Now, that's reflected. And then, if it's moved so that it has a new turning point, what we can do is we can just simply write this in turning point form. So we can say, righto, that means that y equals, we've got a value, that's the -5 here, okay? So the -5 goes out the front, and then we fill in the rest of we've got a turning point of -7,4, so it becomes a +7 here as our h value, and then we have a +4 on the end, okay? Now, if you've forgotten, I've gotten this from the formula or the turning point form. And you should just watch the previous two questions. You can see that, okay? So that is when it is translated. Now, occasionally what they're going to do, if I take an aside here, is they're going to ask you to describe what's happening here, and there's some particular language that you need to use around this. If that was the case, what you would have to do is you would have to say, right, so first step, y equals -5x squared, okay, and this is a reflection. Of the graph. Y equals 5x squared, okay? And then you'd say, okay, now if I add on to that, y equals -5x plus 7 squared. This is a translation of the graph -5x squared by 7 units to the left. And then we'd say y equals -5 x plus 7 squared plus 4 is a translation of the graph y equals -5 outside of x plus 7 squared by 4 units up. So we can see that the h value is what shifts it left and right, and that the k value is what shifts it up and down. Now, this description is not necessary in this question. This is just an extension. If you were asked to describe it, this is the correct language to use. All right, question 5 is a little different to the ones that we had back on the first page. So questions 2 and 3, we had to use a turning point form to solve. This time we don't have a turning point. We've got 2 x-intercepts and we've got a y-intercept. So another name for what we're about to do is called the intercept method. And what we're going to do is we're going to take the formula or the form y equals a outside of x minus w multiplied by x minus t. Now, if you look at formula sheets, often b and c will be used instead. It's a bit like the turning point form. We just use w and t so we don't get confused. The little negative symbols in there are just to help you remember that you have to reverse the x values, okay? So this will become our w value, this will become our t value, and our y-intercept we'll just use as a random xy coordinate that we substitute in to solve for a, just like we did with the turning point. So first of all, we'll sub in our w and t's. Still don't know what a is. W goes in as a -1, t goes in as a -7, and now what we're going to do is we're going to take this xy coordinate and we're going to substitute it in so that we can solve for a. So y becomes 14, still don't know what a is, x becomes 0, and x becomes 0 again. So what we have here is 14, and then we've got -1 times -7 makes +7 groups of a. Switch over to balance method, divide by 7 on both sides, and we'll find that a is 2. And now all we need to do is rewrite our original equation that we were forming, so that's this one here, but we'll substitute in our a value instead. So we'll have y equals 2 outside of x minus 1, x minus 7, and this is our completed equation. It doesn't tell me that I need to move it into expanded form, so I'm going to leave it in factorized form to save time. Question 6 is where they're trying to give us a real-world example of where we might have a look at one of these curved lines, these quadratics. Just remember that even though there's all these words here, we're still looking for exactly the same things as in every other question. We're looking for y-intercepts, which this time we're going to call h-intercepts because we've got height this time and we've got distance. So this one's really h-intercept. I'm just going to leave it as a y so that it's not as confusing. We're going to have x-intercepts, which technically this time are actually going to be d-intercepts. And we're going to have a turning point. Now the question doesn't look like it's asking for that, but it's asking for the maximum height, okay? That's just simply a turning point. So obviously this is going to travel up and down, and just here is going to be its maximum height, which is also its turning point. So we're not really doing anything new here. What we'll do is we'll label that up so we don't forget. That's going to be a turning point there, okay? And it's also going to be asked for the distance which this is obtained. Okay, so really all we're looking for here are the x values normally, or the d values. So let's have a look. We will see that the equation, if I rewrite it, looks a bit more friendly in this format. You don't need to do this, but this just makes it look like every other question that we've answered, so it makes life a little easier for us. First of all, I'm going to go looking for my y-intercept. Now I can see that there's no constant on the end, it's missing. That means that it's 0. So my y-intercept, h-intercept, will be 0, 0. That's going to be down here. Next, I might find my x-intercepts like I normally do, so I am going to factorize this using the null factor method. So when h is 0, factorize this, I'll take minus 3 d groups of d outside of d plus 64. Sorry, that's minus 64. Because minus 3d's times minus 64 makes positive 190 groups of d. And so that means that my d values, which we'd normally be looking for our x values here, will be 0, and that comes from here. And they'll also be positive 64, and that comes from this number here, just like when we're doing null factor law normally. So my d-intercepts are going to occur at 0, 0, and also at 64, 0. In other words, the first one's going to happen at the same point as the y-intercept, and the other one's going to happen over here somewhere, and we're going to have a curve that looks something like that. Next, we need to find our turning point. So we do that the same way. One of the ways that we can do that is we can find halfway between 0 and 64. So that means that our turning point, our distance value, is going to be 0 plus 64 divided by 2, which gives us a value of 32. And I can find out what my height would be of my turning point by substituting 32 in place of d in our original equation. So we'll go back and pick that up from here. So what I find is that the height of the turning point will be minus 3 groups of 32 squared plus 192 times 32, which will give me a height of 3,072 meters. Now, all I need to do is plot this and then answer it. So I've got to give our table some values. I might make this 5,000 meters. I might make this about 2,500, and we might span a distance of 100 meters. So that puts our first intercept here at 0, 0. That will be our x-intercept and our y-intercept. And then we've got our second one about here, which is where d is 64, y is 0. And then we're going to need to find our turning point, which is going to be when d is 32, y is going to be 3,072, which should land us up about here. And then I'll draw my curve. Oops, draw my curve. And I'll label my turning point, which occurred at 32, 3,072, which also happens to be my maximum height. Now, it's a worded question, so we're going to answer it in words. It said, find the vehicle's maximum height and the distance which this is attained. So we will give ourselves an answer, something to the effect of maximum height was 3,072 meters at 32 meters from the starting point. And that's our answer. How high is the vehicle at a distance of 4.2 meters from the launch pad? This is really just a substitution question. So we've got that the d value is 4.2. All we need to do is go back to the original equation. We might even go right back to the very original equation here, okay? And we'll say, okay, if the original equation is that the height is 192 groups of d minus 3 groups of d squared, all we have to do is replace the d's with 4.2s. Pop it in our calculator, and the answer will be 753.48 meters. Question 7, we're sketching a graph. We need to show x, y, intercepts, and the turning point. So it's in expanded form, so straight away we can see the y-intercept. So we'll just start collecting them over here. We need y-intercept. We need our x-intercepts, and we want our turning point. So our y-intercept is going to be when x is 0, y is 15. Our x-intercepts, to find that, easiest way to do that is to factorise this using null factor method. So we'll say, instead of writing y equals x squared minus 8x plus 15, we're going to need to factorise it. So when y is 0, I know that this is going to be one of those ones that looks like this. I'm looking for factors of 15 that will make minus 8. I've got 1 and 15. I've got 3 and 5. That's looking pretty good. The next thing is, I'm just having a quick look at this symbol here. If that's a positive, that means that both brackets will have the same symbol in them, plus or minus, and this tells me that they'll both be negative. So I can fill that in. I'll choose my factors 3 and 5, and minus 3 minus 5 makes minus 8. So I've successfully factorised that, which means that my x values are positive 3 and positive 5. So that means that my x-intercepts are when x is 3, y is 0, and when x is 5, y is 0. I just need my turning point. Now, one of the ways to find the turning point, a nice easy way to find the turning point, is to find halfway between your x-intercepts as your x value of your turning point. So we say 3 plus 5 divide by 2 gives me 4. So if I have an x value of 4 and I put it back into my original equation, this one up here, I can go, great, that means that y is going to be 4 squared minus 8 times 4 plus 15, which gives me an answer of minus 1. So that gives me a turning point of where x is 4, y is minus 1. And now all I've got to do is get this on the graph. I'm noticing that the y-intercept's quite large, so I'd normally just scale these to 10s, but this time I'm going to make them to 20s so that it fits. It's important you put a scale on. That means that my y-intercept is going to occur here, where x is 0, y is 15. Means that my x-intercept is going to happen here, where x is 3, y is 0, and it's also going to happen here, so where x is 5, y is 0, just being conscious of space here, and then I've got a turning point at 4 minus 1, which is going to happen here. So my turning point will be where x is 4, y is minus 1, and then I'll sketch my curve. And this question is completed.